Hello there, and welcome to the calm space of LUMIVERSE NL, a calm space where science drifts like a dream. Tonight, we leave behind the warm light of our own solar system and set our course into the deep, dark between stars. Here, far beyond the sun's familiar glow, other planets orbit distant suns, each one stranger and more beautiful than imagination allows. Some shimmer like jewels of vaporized metal. Others burn with heat so fierce it bends the very rules of nature. And yet, all of them are real. Quiet worlds turning endlessly in the dark. As the music settles around you, let your body rest. Let your breath match the slow rhythm of the cosmos. Every exhale a little further from the noise of Earth. Every inhale a little deeper into the silence of space. Because tonight, we travel through planets that defy what we once thought possible. Worlds of fire and ice, of glass and diamond, of light and shadow intertwined. There are planets so hot that even metals melt in their skies, glowing like drops of starlight. Others are colder than frozen gas, silent spheres adrift in perpetual night. Some orbit two suns, bathing in twin dawns that paint their skies in colors unknown to Earth. And some wander alone, untethered, starless, drifting through infinity. Each one tells a story, and together they remind us that creation does not end with what we see. It continues quietly everywhere. Astronomers call these worlds exoplanets, planets that orbit stars beyond our sun. We've discovered thousands of them, each with its own rhythm, chemistry, and light. Some resemble our home. Others feel like fever dreams sculpted by gravity and heat. They form from the same cosmic ingredients: dust, gas, and time. Yet the results are endless. In every discovery, we glimpse another version of what a world can be. Imagine standing on a world where the sky rains molten glass, or on another where mountains are made of solid carbon crystal. There are planets that reflect almost no light at all, darker than coal, and planets that shine brighter than Venus, glowing mirrors orbiting their suns. Some have oceans so deep they could swallow continents. Others are locked in eternal daylight on one side and eternal darkness on the other. Each possibility expands our sense of what home might mean in the universe. It's humbling, isn't it? To realize that our small blue world is just one among billions, a single melody in an orchestra of endless variation. The cosmos is not empty. It is alive with worlds, each one turning silently, patiently, unseen. So as you listen tonight, let wonder replace thought. Let stillness replace sound. Somewhere out there, a new planet is forming. A swirl of gas and dust finding its balance in the dark. Somewhere else, another world is dying, its atmosphere stripped away by its star. And in between, countless others keep turning. Proof that creation never sleeps. Rest your mind. The journey begins here. In the space between curiosity and calm, where science becomes serenity, and every fact drifts like a lullaby of light. There are planets so hot that even the air itself begins to melt. Worlds where metals rise into vapor, swirl through storms and rain back down as molten fire. Among these infernos is one of the most extreme ever found. Kelt 9b, a gas giant orbiting a massive blue-white star 670 light-years away. Kelt 9b is unlike anything in our solar system. Its dayside temperature reaches nearly 7,000 degrees Fahrenheit, hotter than many red dwarf stars. It orbits so close to its sun that a single year there lasts just over one Earth day. Locked by gravity, the same hemisphere always faces the star, trapped in endless daylight. On that side, the atmosphere glows like a forge. Molecules tear apart under the heat. Metals turn to gas, and hydrogen escapes into space in a comet-like tail. It is not just a planet, it is a living flame, circling a sun that burns it alive. Astronomers call such worlds ultra-hot Jupiters. They challenge every rule we once believed about planetary stability. In these infernos, chemistry behaves like poetry written in plasma. Iron, titanium, and magnesium exist not as solids, but as vapor drifting through superheated winds. Spectroscopic readings show that clouds cannot survive here. Even the shadows dissolve into light. Every orbit strips a little more of the planet away, its atmosphere bleeding into the dark. And yet, it endures. A storm of glowing gas clinging to gravity, refusing to vanish. If you could stand on its night side, you would see the star's light refracted into a dim, bloody shimmer, while above you, the sky would curve in metallic waves. But you could not stand at all. There is no solid surface, only boiling layers of gas, each one hotter, brighter, and more violent than the last. Kelt 9b reminds us that the universe's imagination is vast, that even destruction can be beautiful when seen from far enough away. Not all heat burns with chaos. In some stars' shadows lie calmer giants, still hot, but slower, heavier, their skies stained in crimson storms instead of pure fire. These hot Jupiters orbit their suns in only a few days. Their outer atmospheres glow faintly, carved by solar winds that shape luminous arcs of escaping gas. To distant telescopes, they shimmer like ghosts, half seen, half transparent, caught between presence and disappearance. Scientists study them because they reveal what happens when planets live too close to light. Their orbits teach us about gravitational tides, atmospheric escape, and the boundaries of endurance. They are laboratories of heat, where matter stretches, atoms unbind, and equilibrium becomes art. From these blazing giants, we learn not only how planets die, but how they live under impossible conditions. The question arises, how can such fragile structures survive for millions of years so near to such violent stars? The answer lies in balance. Even at 7,000 degrees, gravity holds the atmosphere just enough to delay its loss. It's a fragile truce between light and matter, a dance at the edge of destruction. And perhaps that's the quiet truth behind all existence, that beauty and peril are twins, orbiting the same fire. So as we drift past this burning world, imagine watching its horizon, a sea of light without shadow, a sun that never sets, and a planet that refuses to stop shining, even as it's slowly undone by its own star. Because sometimes, in the vast laboratory of the cosmos, even endings can glow. There are planets where heat is not just a number, it's a force that shapes reality itself. Among these blazing worlds stands one of the most extreme ever found, Kelt 9b. A gas giant circling its star so closely that it completes an orbit in just over one Earth day. That means every sunrise and sunset happen in less than 25 hours, if you could even survive to see them. Kelt 9b is scorched by the light of a blue-white sun more than twice as hot as ours. Its day side burns at over 7,000 degrees Fahrenheit, hotter than many red dwarfs. At that temperature, the atmosphere becomes a sea of plasma. Hydrogen, iron, and titanium rise into the air as vapor. Molecules split apart. Metals melt into invisible storms. The planet's atmosphere is being torn away. Streaming behind it in a long glowing tail like a comet adrift in fire. Astronomers call such worlds ultra-hot Jupiters, planets that blur the boundary between planet and star. They orbit so close to their suns that gravity locks one face in permanent daylight, while the other is trapped in eternal night. One hemisphere glows white-blue, while the opposite side falls into a blackness deeper than space itself. Between them lies a ring of turbulent twilight, a belt of furious winds racing at thousands of miles per hour, trying endlessly to carry heat from one side to the other. Nothing about this world is still. Every particle moves, collides, escapes. The air itself screams across the horizon. If you could stand near it, though you never could, the star would fill half your sky. And the light would be so fierce that even shadow could not survive. Kelt 9b teaches us something profound about endurance. Despite the chaos, it remains in orbit, bound by gravity's quiet persistence. It loses mass with every turn, shedding gas into the void, yet it continues to exist. A flame that refuses to go out. In time, it will fade, stripped down to darkness. But for now, it glows. A monument to balance at the edge of annihilation. From a distance, telescopes capture its faint, spectral fingerprint. Tiny shifts in light that reveal what it's made of. That shimmer, traveling across centuries of emptiness, tells us that even a world of fire can be studied in silence. And maybe that's the lesson hidden in its orbit. That beauty isn't only found in comfort or calm, but also in the places where matter struggles to hold together against the impossible. The universe, it seems, does not fear extremes. It creates them, it sculpts planets out of heat and pressure, and then lets them dance in front of the stars, blazing briefly before dissolving into shadow. So tonight, as you listen, imagine this world turning slowly through a storm of light. A reminder that even in the most violent places there is rhythm, there is motion, and there is peace in knowing that every spark, no matter how brief, is still part of the same quiet universe. If Kelt 9b is a world of flame, then the next planet belongs to darkness and pressure. A realm where heat forges not destruction, but beauty. It is said that under the right conditions, a planet could be made almost entirely of diamond. It sounds like myth, but science suggests it could be real. Astronomers believe that some stars, rich in carbon rather than oxygen, give birth to planets with a different chemistry. Worlds where carbon becomes the foundation, where every mountain, every grain of dust, might shimmer with hidden crystal. Among these possibilities is a place known as 55 Cancri E, a rocky super-Earth twice the size of our planet, orbiting a bright yellow star 40 light-years away. Surface temperatures there exceed 4,000 degrees Fahrenheit, hot enough to melt metal, to vaporize stone. And deep beneath that molten shell, the immense pressure could compress carbon into something extraordinary. Vast, subterranean layers of solid diamond, locked away in eternal darkness. Not the sparkling jewelry we imagine, but an alien geology of crystal and heat, a world gleaming within itself, unseen. If you could descend into its depths, the air would thicken into vaporized carbon. The ground would glitter faintly under your steps like starlight trapped in rock. It wouldn't feel alive in the way Earth does. It would feel ancient, silent, a monument to the universe's ability to create beauty through violence. 55. Cancri A reminds us that matter remembers. Carbon that once floated freely in a stellar nursery has become something precious, pressed and reshaped by time into crystalline endurance. Every gem on Earth is a whisper of the same process, born from pressure, surviving through transformation. Perhaps the entire planet is a metaphor written in physics, that even under unbearable weight, something perfect can emerge. That brilliance is not the absence of darkness, but the product of it. In the quiet hum of the cosmos, a diamond planet circles its star, too bright to see, too distant to touch, but real all the same. And as we drift past it tonight, let its story settle gently in your mind. That beauty can be forged from chaos, and even in the heart of pressure, light endures. In the imagination of storytellers, two suns sinking beneath a distant horizon once belonged only to fiction. A symbol of wonder, the twin sunset of a galaxy far, far away. But today, science confirms what myth first dreamed. There are planets that truly orbit two stars at once. These are known as circumbinary planets. worlds that dance between dual suns bound together by gravity. They don't belong to one light, but two. And their skies are among the strangest in the universe. Imagine standing on the surface of such a world. The day begins with one sun rising while the other still hovers above the horizon. As the sky brightens, the colors blend into hues unseen on Earth. Copper, violet, and silver light swirling together. When the first star sets, its companion remains, stretching the day longer than any we know. And at night, even darkness glows faintly, lit by the reflection of twin suns shining from afar. To exist in such a system is to live inside a celestial duet. The two stars orbit each other, their gravitational waltz creating a center of balance. And around that invisible point, the planet moves, tracing an intricate loop through the ever-changing light. Some of these stars are close together, so the planet orbits both as though they were one. Others are far apart, and the planet weaves between their competing poles, its path forever bent by a tug-of-war written in starlight. Astronomers have observed several of these rare systems, each one a delicate balance between chaos and harmony. In some, the twin suns are nearly the same size, glowing yellow and orange, locked in slow orbit around one another. In others, one star is a dim ember, the other a blinding flame, so that day and night blur into shimmering gradients of color. Life on such worlds, if it exists, would adapt to a rhythm beyond our imagination. Seasons could shift unpredictably, depending on the alignment of the stars. One hemisphere might bask in long, overlapping summers, while the other endures ages of dusk. Shadows would come in pairs, stretching and crossing as each star moves across the sky. The concept of noon might vanish entirely, replaced by an endless sliding spectrum of light and warmth. From a distance, these planets appear serene, two suns glowing beside each other like candle flames in a dark room. But their orbits are fragile. A small change in gravity could scatter them into chaos, and yet they persist, held together by invisible precision, as if the universe itself prefers rhythm to disorder. One of the first circumbinary planets ever confirmed was Kepler 16b, nicknamed Tatooine, after its fictional counterpart. It's a gas giant, cool and orange, orbiting two stars roughly 200 light-years away. When NASA's Kepler telescope detected it, it became a symbol of how imagination and science sometimes meet in the same sky. A world once confined to cinema had stepped quietly into reality. There may be hundreds more like it, some rocky, some gaseous, some hidden in the glare of their suns. Each one a living proof that the universe writes variations even into the simplest themes. Where we imagined one sun, it gives us two. Where we thought stability was rare, it offers harmony born of movement. And as we drift among these twin-lit worlds, it's hard not to feel a sense of quiet awe that somewhere, perhaps tonight, two stars are setting side by side over a foreign sea, casting twin reflections on waves that no one will ever see. A sight both utterly alien and deeply familiar. Because maybe that's the lesson of circumbinary worlds. That beauty often exists between forces pulling in opposite directions. That balance is not stillness, but motion held in grace. So if you ever look up and find two lights shining in the same sky, one warm, one pale, remember, somewhere out there, a planet lives under both. And as those twin suns sink together beyond a horizon of clouds, they leave behind not darkness, but the golden memory of shared light. There are worlds so alien that even their weather seems born from dreams. Skies of sapphire blue, winds faster than any storm on Earth, and rain, not of water or ice, but of molten glass. This is the world of HD 189733b, a gas giant more than 60 light-years away, orbiting its star so closely that a year there lasts only 2 days. At first glance, it looks serene, cloaked in a deep blue hue that resembles our own planet. But that color is an illusion. Its beauty hides a storm unlike anything humanity has ever known. HD 189733b is a world where the atmosphere burns at 1,700 degrees Fahrenheit, where winds howl at over 5,000 miles per hour, and the very air is laced with silicate particles, the raw material of glass. When the heat and pressure collide, those silicates condense, forming droplets that fall through the atmosphere as liquid glass rain. Except nothing falls straight here. The wind blows sideways at hurricane speeds, turning each drop into a horizontal blade of molten crystal, flashing blue in the light of a distant sun. From far away, the planet gleams, a jewel adrift in the dark, reflecting starlight like calm ocean water. But up close, it is a world in chaos, a roaring furnace wrapped in beauty. If you could hover above its clouds, you'd see ribbons of light twisting across its horizon. Each gust of wind scattering glass particles through layers of vaporized metal. Lightning would streak through the haze, illuminating the clouds like flashes of electric sapphire. It's a storm that never ends, a cycle of heat and wind and glass that has likely raged for millions of years. Astronomers have long been fascinated by this planet's deceptive calm. Its color, once thought to come from oceans or thick clouds, is instead the reflection of those airborne minerals scattering blue light. In a way, it mirrors Earth, not in what it is, but in what it appears to be. Both worlds shimmer in blue, but one cradles life, while the other is a storm without mercy. The contrast is humbling. It reminds us how fragile beauty can be, how appearance often disguises extremes. HD 189733b shows us that nature does not need comfort to create something breathtaking. Even a world made of glass and fire can glow with a serenity that feels almost peaceful from afar. When the planet crosses in front of its star, the starlight filters through its atmosphere, revealing spectral traces of iron, magnesium, and vaporized silicate. Those tiny distortions in light are how we know its story, not from sight, but from shadow. We can't see its surface, but we can read its storms written in color and heat. And that is one of astronomy's quiet miracles. We learn to see through darkness by measuring the way light trembles. Every flicker carries a signature, every dip in brightness a whisper from a world we cannot touch. In the case of HD 189733b, that whisper says, "I am beautiful, but I am not kind." A world of eternal storms, forever sculpting glass in its sky. Yet, even in its violence, it belongs to the same universe that gave us soft rain, gentle oceans, and blue skies of our own. It proves that chaos and calm are siblings, born from the same laws, the same starlight, only separated by distance and chance. So when you gaze into the night and see a blue star shimmering faintly, remember that somewhere near it spins a planet wrapped in wind and fire, a mirror of color but not of peace. A world that teaches us that beauty does not always mean safety, and that even the most violent storms can shine with quiet grace. For in the silence of space, the glass rain still falls, and the winds still carry their crystal song across an endless horizon, far from any sun we know. There are worlds that drift beneath endless oceans, planets where the surface never meets the sky, where land does not exist, and water is the only horizon. Astronomers call them ocean worlds, planets covered completely by deep, global seas that stretch for thousands of miles. No continents, no islands, no mountains breaking the surface, just a boundless expanse of shifting blue, a living mirror reflecting the faint light of a distant star. On Earth, the deepest point in the ocean sinks about 7 miles beneath the surface. But on these planets, the ocean could reach depths of hundreds, even thousands of miles. Beneath that unimaginable weight, the water transforms into something strange. Exotic, high-pressure ice, denser than rock, crushed by gravity into forms that cannot exist here. Imagine standing on a ship that never finds land, sailing through an atmosphere filled with mist and vapor. The sky dim and quiet, the sea beneath you darker than ink. Beneath that surface, layer after layer of pressure builds until the water freezes from weight alone, forming massive ice mantles that encase the planet's hidden core. Some of these worlds might still hold warmth deep below, internal heat left over from their formation or generated by tidal forces from nearby moons or stars. That warmth could melt portions of the lower ice, creating hidden oceans beneath the frozen crust. Oceans that never see light but might still stir with motion. There, in complete darkness, life could take shapes we can't yet imagine. Scientists believe planets like these may be common in the galaxy. In fact, water may be one of the universe's most abundant substances. And wherever there is water, the possibility of life follows. But life here would not resemble the life we know. There would be no trees, no birds, no fire. Perhaps only microscopic organisms, floating in the warm chemical haze beneath the pressure, feeding on minerals drawn from the planet's interior. To them, the concept of a sky would be myth. Light, an ancient dream carried through generations of memory. Their world would be eternal twilight, defined not by seasons or sunlight, but by tides and temperature. A slow, breathing ocean that has never known a shore. From a telescope's view, these ocean planets look like tiny blue dots, their color softened by clouds of vapor. At first, they might seem familiar, even comforting, as though they could be second Earths waiting to be discovered. But their seas are deeper, their skies thicker, their calm a quiet illusion hiding the weight of eternity. Yet there is something peaceful about them. To imagine a planet completely wrapped in water is to imagine a place without borders, without division, a world unified by motion, by the steady rhythm of waves circling forever beneath the stars. They may be lonely, but they are whole. When astronomers study the faint light passing through their atmospheres, they search for the chemical fingerprints of vapor, for hints of hydrogen, oxygen, or salt, the echoes of oceans that have never been seen. Every discovery brings us closer to understanding how rare and how common life might truly be. And if there is something living in those vast abyssal depths, it has never known sunlight, it has never seen a sky, but it has endured, breathing, evolving, and adapting beneath pressures that would crush any earthly creature. It would be life born not from warmth or air, but from patience, the quiet persistence of molecules finding harmony in darkness. So when we look at these gentle blue worlds floating in the void, we see not just water, but potential, not emptiness, but waiting. Because in every drop, in every hidden current flowing beneath an alien sea, there may be the memory of our own beginnings, a reminder that life, in all its fragile forms, always finds a way to float. Even in the silence of a starless ocean, something may still be listening, drifting softly through the deep, carried by the slow heartbeat of a world made entirely of water. Some worlds never turn. They do not spin with the gentle rhythm of day and night as Earth does. They are tidally locked, their rotation captured by the gravity of their star. One hemisphere scorched by unending light, the other frozen in endless shadow. From afar, these planets look perfectly balanced, half bright as a torch, half black as coal. But up close, they are worlds of extremes, where the boundaries between life and death, light and dark, are drawn by gravity itself. On the day side, the heat is relentless. The sun never moves from its place in the sky, a blazing, eternal noon. The air shimmers at thousands of degrees, and metals may melt into rivers that crawl across the glowing surface. The sky is white, searing, featureless. If any clouds form, they rise only to evaporate into steam. On the night side, the story reverses. There, the sun has never risen. Temperatures drop far below freezing, and the air, if it exists at all, crystallizes and falls like black snow. This is a place where silence is absolute, where the only motion might come from winds howling across the terminator, the thin twilight band dividing the two hemispheres. And it is here, in that narrow ring between fire and frost, that some scientists believe life might find its refuge. The twilight zone, they call it. A region where light is dim, the temperature moderate, and the winds circulate between extremes. It's the balance point of an impossible world, a place where dawn and dusk never end. Imagine standing there. To your east, a sun locked in the same place forever, casting the same long shadows day after day. To your west, a horizon that never brightens, the darkness endless, untouched. You would live in eternal evening, where the light is never gone, but never whole. Atmospheric models suggest that on some tidally locked planets, winds could flow at thousands of miles per hour, driven by the constant tug between hot and cold. Those currents might carry clouds from the day side into the dark, where they condense and fall as frozen rain before drifting back again. A planet breathing in slow motion, inhaling light, exhaling shadow. If such a world had oceans, they might pool in the twilight zone, where the warmth is enough to melt ice but not to boil water. There, beneath a permanent sunset, waves could rise and fall under skies of faint orange and violet. It's a haunting beauty, a world balanced forever on the edge of light. For a long time, scientists doubted such planets could host life, but new simulations suggest that strong winds and ocean currents could evenly distribute heat, keeping parts of the planet temperate enough for liquid water, and maybe even life itself. Life that thrives not in light or darkness, but in the gentle equilibrium between the two. To us, such a place might seem desolate, but perhaps for its inhabitants, if any exist, it is the only world they could imagine. A place without sunrise or sunset, without change or chaos, only constancy. The comfort of a sky that never moves. And maybe that constancy holds a kind of peace. The universe, after all, is not built only on motion. Sometimes, balance is achieved through stillness. So if you could drift above a tidally locked planet tonight, you would see one side blazing like a furnace, the other black and silent as the void, and between them a thin golden curve, the twilight belt where warmth meets cold, and perhaps life quietly endures. A planet forever turning toward its star, forever reaching into the dark, its existence a slow and perfect compromise between the two most ancient forces of all, light and night. Imagine a planet the size of Jupiter, vast, gaseous, and majestic, but drawn so close to its star that the heat begins to strip it apart. Its atmosphere boils, its clouds are torn into glowing streams of gas, and its outer layers drift into space like a shimmering veil. These are the hot Jupiters, giant planets orbiting their suns at impossible proximity. They complete a full orbit in just a few days, some in less than 24 hours. At such distances, the heat is fierce enough to vaporize rock, and the gravitational pull so strong that their atmospheres stretch into elongated shapes, swelling like lanterns caught in a solar wind. To understand their story, we must return to how planets form. In the quiet disks of gas and dust that surround newborn stars, gas giants like Jupiter are thought to form far away, where ice and gas can accumulate without burning away. But somehow, these giants move inward, drifting closer and closer until they skim the edge of their star's fire. The process is called planetary migration, a slow dance of gravitational exchange that can take millions of years. No one knows exactly how these hot Jupiters survive the journey. Some are likely destroyed, their atmospheres peeled away until only cores of heavy elements remain. Others find a delicate balance, locked in tight orbits where gravity, heat, and motion sustain a fragile stability. From a telescope's view, these worlds reveal themselves as flickers of shadow, tiny dips in a star's brightness when the planet passes in front. Through those dimming patterns, astronomers can measure their size, mass, and orbit. But it's their spectral fingerprints that tell the deeper story. Signatures of sodium, potassium, titanium oxide, and other molecules baked in relentless radiation. Some of these planets glow faintly in infrared light, their day sides so hot they emit heat like a dying ember. To witness one is to see the edge of endurance. The winds on these worlds can reach 12,000 miles per hour, ripping across hemispheres, carrying plasma and vaporized metals from one side to the other. Each sunrise is not gentle. It is a wave of radiation sweeping across the sky. The boundary between day and night glows faintly blue as atoms recombine after being torn apart by heat. One of the most studied examples is WASP 12b, a hot Jupiter orbiting its star once every 1.1 Earth days. It's so close that its gravity is distorted. The planet stretched into an egg-like shape. Over time, its star is literally consuming it, drawing gas from its outer layers into a swirling stream of light. Astronomers believe it may vanish completely within a few million years, leaving behind nothing but traces of heavy metals, ashes scattered across a solar graveyard. And yet, even as they die, these planets tell us about survival. Their brief lives show how nature experiments with boundaries, testing what can exist, how close matter can come to destruction before becoming something new. Each discovery forces scientists to rewrite the rules of what a planet can be. Some hot Jupiters glow bright blue, their colors sculpted by exotic chemicals and molten atmospheres. Others appear dull and dark, their clouds made of metal and glass. Some are losing mass so quickly that they leave comet-like trails of vapor, stretching for millions of kilometers into the void. They are, in a sense, the phoenixes of the galaxy, born from dust, consumed by flame, and reborn as light in the eyes of distant observers. To watch one transit its stars to see a story unfold in seconds, a shadow crossing the face of brilliance, a brief interruption in the light that tells of a giant world struggling against its own fate. In that flicker, we glimpse the fragility of all things bound by heat and gravity. And if you think of it quietly, perhaps there's something familiar in that struggle. A reflection of our own world, small, warm, precariously balanced between extremes. Because, like those distant giants, we too live close to the edge of our sun's warmth, sustained not by permanence, but by balance. So when the next flicker appears in a star's light curve, remember, behind that tiny dimming lies a world of flame. A planet fighting to exist for just a little longer beneath a sky that never cools. And as it turns, dissolving into the brightness of its star, it leaves behind a whisper, carried on solar wind, even in the fiercest heat. Something still holds on. Not every planet shines in the light of its star. Some swallow that light almost completely, absorbing everything that touches them, as if they were made from the very essence of darkness itself. One such world is TRES-2b, a gas giant orbiting a yellow star about 700 light-years away. It reflects less than 1% of the light that reaches it, making it darker than coal, darker than fresh asphalt, darker even than the black paint used to trap light in telescopes. To the human eye, it would appear not as a world, but as a silhouette, a moving absence in the starlight. Astronomers call planets like this ultra-dark Jupiters, giant worlds wrapped in atmospheres that devour reflection. Their darkness is not emptiness, but chemistry, clouds of vaporized metals, and exotic compounds that absorb nearly every wavelength of visible light. Some theories suggest that alkali metals like sodium and potassium combine in strange ways under immense heat, turning the sky into a mirror that reflects nothing. If you could approach TRES-2b, you would see almost nothing until the light of its star grazed the edges of its atmosphere. A faint, crimson glow, a dim halo marking where gas still burns. Even its night side, already shrouded in shadow, remains only slightly cooler than the day, its heat trapped by layers of carbon haze and metallic vapor. It is a world that hides from the universe, absorbing its own light and offering none back. And yet, somehow it still shines. Not through reflection, but through the faint infrared radiation it emits. A whisper of warmth, a silent pulse that tells astronomers it's there at all. To detect it, telescopes must measure the tiniest variations in starlight, watching for a dimming smaller than 1 part in 1,000. The precision required is extraordinary, and yet the signal is unmistakable. A dark planet passing before a bright star, its shadow revealing more than its surface ever could. Why would nature create such a world? Perhaps because the universe loves contrast. For every world of light, there must be one of darkness. For every glittering planet of diamond and vapor, there must be another that swallows the stars. TRES-2b is not alone. There are others, planets so dark that they seem to erase light as they move. Some orbit stars much larger than our sun, their atmospheres seared and carbon-rich. Others are cooler, with clouds thick enough to absorb nearly everything that strikes them. The result is the same, a darkness so perfect that even light itself seems uncertain how to behave. To stand near such a planet, if it were possible, would be to experience a sky without horizon. No reflection, no shimmer, no contrast. Only the faint suggestion of a star's glow, the air heavy and silent, as though the universe were holding its breath. And yet, within that void, there is elegance. TRES-2b reminds us that beauty is not always bright, that sometimes meaning lives in the quiet places, in the unseen, the unnoticed, the parts of the cosmos that choose silence over spectacle. We often associate light with knowledge and darkness with mystery. But the truth is, the universe needs both. Without shadow, there can be no definition. Without contrast, there can be no depth. This planet, invisible against the fire of its sun, exists to remind us that darkness, too, is part of creation. Somewhere between starlight and shadow lies the essence of balance, the delicate point where what is seen and unseen coexist. TRES-2b lives there, orbiting quietly, a planet that does not glow but endures. And perhaps that's its quiet gift to us, to show that not everything bright is alive, and not everything dark is dead. Even in a universe built from light, there must be places for light to rest. And there, in the stillness of a star's reflection, a world like this can drift forever. A shadow with a heartbeat, a darkness that glows faintly from within. Because even the deepest blackness cannot exist without remembering the light it once received. Most planets circle a sun, held steady by its light and warmth. But some wander alone, cold, unanchored, drifting through the dark between the stars. These are the rogue planets, the orphans of the galaxy, worlds that travel without a home. Unlike Earth or Jupiter or any planet in our solar system, rogue planets do not orbit a star. They drift freely through interstellar space, their paths unbound by light. Some were born in ordinary systems but later cast out, flung into the void by the gravitational chaos of their youth. Others may have formed alone, from the same cosmic dust that makes stars, but never gathered enough mass to ignite. To imagine such a world is to imagine silence beyond silence. No sunrise, no sunset. No seasons, no shadows. Only the eternal night of deep space. The surface would be frozen. The air, if it existed, turned brittle by the cold. The planet's only warmth would come from its own core, the faint memory of formation still glowing deep within. And yet, that faint heat might be enough. Some rogue planets could still have subsurface oceans, hidden beneath layers of ice, kept liquid by geothermal energy or radioactive decay. In those dark waters, life might endure, yet not thriving in sunlight, but in the quiet chemistry of heat and time. Astronomers believe there may be billions of these wanderers drifting through the Milky Way. They are difficult to detect, invisible light, but occasionally their gravity betrays them. When a rogue planet passes in front of a distant star, it bends the starlight, magnifying it for just a moment. This phenomenon, called gravitational microlensing, allows us to glimpse the unseen, a brief flicker in the vast darkness, like a heartbeat felt through the fabric of space. Every detection feels like finding a ghost, a world adrift, unlit, unseen, moving slowly through eternity. There are no skies here, no constellations, only the faint glow of galaxies far away, the cosmos reflected on the ice of an endless winter. If you could stand on the surface of such a planet, you would see the universe not as points of light, but as a luminous sea surrounding you on all sides. Each star would be fixed, unmoving, the same view for all of time. The silence would be so complete that even thought might sound loud within your mind. And yet, there's beauty in that solitude. These worlds may seem lost, but perhaps they are free, unbound by orbits, unburdened by suns. They drift through the galaxy as cosmic monks, carrying with them the stillness of deep space. Scientists suspect that some of these planets may once have had moons. If those moons remained, they could orbit the planet even in darkness, their motion the last trace of companionship. Imagine a frozen world, wrapped in the gravity of its own past, a single moon circling endlessly, its light too faint to see but too loyal to fade. There's a quiet poetry in that image, a world that lost its star but not its rhythm, a planet that, though unseen, continues to turn. Some rogue planets may even pass near other star systems, briefly illuminated by alien light before fading again into blackness. If any traveler could stand there and look outward, they would see stars rise and fall over eons, not in days or months, but in ages. Each star a stranger, each encounter fleeting. The universe is full of such wanderers, worlds that were born, lived, and were exiled into infinity. And though they drift without destination, they remind us of something profoundly human, that motion itself is a kind of purpose, that even in the absence of light, there is still the will to keep moving. So the next time you look up and wonder where life might hide, remember the ones that carry their light inside. Somewhere between the stars, a lonely planet is gliding silently, wrapped in the memory of a sun it no longer sees. And as it passes through the dark, its core still glows softly, not bright enough to shine, but enough to prove that warmth, like hope, can survive even when the sky forgets your name. Worlds we've only just begun to imagine. One of these strange worlds is HAT P7b, a gas giant that orbits its star every 2 Earth days. There, the day side burns at more than 4,000 degrees Fahrenheit, hot enough to melt stone. But on the cooler night side, scientists believe mineral clouds may form. Crystals of sapphire and ruby suspended in the upper atmosphere, sparkling as they're swept from night to day by winds reaching thousands of miles per hour. If you could float above its surface, you would see a world lit by shifting patterns of color. The sky would not be blue or gray, but a living prism of heat and reflection. Each gust of wind would scatter the crystals like dust made of stars. Lightning would flicker in shades of rose and indigo. Even the dark side would not be truly dark, only glowing dimly with the reflected glint of gemstone clouds churning far above the invisible surface. It's difficult to imagine standing beneath a sky like that. A canopy of moving fire, each shimmer the reflection of something solid, now turned to mist. The physics that shape these worlds feel more like dreams than science, and yet every observation confirms their existence. The telescopes that capture these colors do not see the clouds directly. Instead, they read the spectral signatures of light filtering through the planet's atmosphere during transit. From these subtle shifts, scientists can tell which minerals are present, how thick the clouds might be, and even how the winds move them. It is, in essence, reading weather from light, a translation of storms into color. And the colors themselves tell a story. Where Earth's skies are blue because of air and scattering, these planets shimmer blue because of sapphire dust. Where our sunsets are orange with vapor and dust, theirs glow crimson with the reflection of liquid gems. It's a reminder that even familiar colors can come from unfamiliar worlds. That the same hue can mean heat, not comfort. Violence, not calm. HAT P7b is not alone. Other worlds show signs of mineral mists and metal clouds. Planets where iron reigns, where silicate particles drift in vast metallic storms. Some may have skies tinted purple by vanadium oxide or emerald by chromium vapor. Each one is an artist's experiment written in physics, painting the same universe in colors we cannot see. These discoveries expand not just our catalog of planets, but our idea of what sky can mean. The atmosphere, it seems, is not merely a blanket of gas. It is a canvas shaped by light and chemistry. And perhaps, as we look deeper into the cosmos, we'll find that color itself is universal. That every world, in its own way, tries to catch the light and hold it for a moment before letting go. Imagine, then, a sunrise on HAT P7b. The star swelling over a horizon of sapphire haze, its light scattering into bands of crimson and blue. The air shimmers, the crystals ignite, and for a few fleeting moments, the planet glows like a jeweled flame. In that instant, somewhere between science and wonder, you might realize, the universe does not simply exist. It performs. Every storm, every color. Every glint of mineral light is the cosmos rehearsing beauty in all the ways we've yet to name. And in the reflection of those gem-filled clouds, we see a truth older than time itself, that even in chaos, the universe remembers how to shine. Among the thousands of exoplanets discovered so far, there is one category that feels strangely familiar, yet also more promising than our own home. They are called super-Earths, worlds larger and heavier than Earth, but smaller than the gas giants like Neptune. A super-Earth might have twice or even 10 times our planet's mass. Its surface could be rocky, its gravity strong enough to hold onto a thick atmosphere. And under the right conditions, that atmosphere could cradle oceans, clouds, and life, perhaps more stable, more enduring than anything we've known on Earth. Scientists once imagined that life could only exist on a world very much like our own, but these discoveries have changed that view. Some super-Earths may, in fact, be more habitable than Earth itself, with denser air to protect against radiation, deeper oceans to regulate climate, and a slower geological rhythm that allows stability for billions of years. One such candidate is Kepler 442b, a rocky planet orbiting an orange star about 1,200 light-years away. It sits perfectly within the habitable zone, that narrow band where water can exist in liquid form. Not too hot, not too cold. It receives about 2/3 of the sunlight that Earth does, enough to keep it temperate, perhaps wrapped in clouds and rain and slow-rolling seasons. If Kepler 442b has oceans, their waves might move under a dimmer, redder sky. The sunlight softer, the shadows longer. Its days would likely pass slower, its years stretching quietly across time. The star it orbits, cooler and older than our sun, might burn for trillions of years, offering life there more time than our world will ever have. Imagine standing on that planet, the ground firm but unfamiliar, gravity pressing just slightly harder against your feet. The horizon would glow in copper hues, the sky tinted orange rather than blue. Clouds could drift in thick, slow formations, and the air, denser, warmer, would carry sound farther and deeper than on Earth. It would feel heavy, ancient, and yet unmistakably alive. The possibility of life on such worlds excites scientists because their conditions might be more forgiving than ours. A super-Earth's stronger gravity could hold a thicker atmosphere, shielding its surface from cosmic rays and keeping temperatures stable even as its star fluctuates. Its tectonic plates might move more slowly, reducing volcanic upheavals and preserving oceans for eons. Perhaps on one of these worlds, life has already begun. Not fragile or fleeting, but persistent, woven into every ocean current and mountain breeze. Kepler 442b is not alone. Others, like Teegarden's Star B, LHS 1140b, and Kepler 62f, share similar conditions. Some orbit red dwarfs that shine dimly but steadily for trillions of years. Some circle multiple stars, their days marked by the rhythm of more than one sunrise. Each one is a quiet candidate for habitability, a reminder that Earth may not be the center of life, but one of countless possibilities. The discovery of these super-Earths has reshaped how we think about our place in the cosmos. It suggests that the balance we enjoy, water, air, warmth, and time, may not be rare at all. It may be the universe's preferred combination, the natural result of physics and patience. And if life thrives on some of these worlds, it might look nothing like us. Perhaps it moves slower, growing under a cooler sun. Perhaps it breathes thicker air, its senses tuned to colors beyond human sight. Or perhaps it thinks, different in form, but similar in wonder, gazing upward and asking the same silent question. Are we alone? Every time a telescope confirms another super-Earth, that question grows softer, less certain, and more hopeful. Because maybe, somewhere far away, a civilization stands on its own copper horizon, watching an orange sun set and wondering if there's someone else looking back through the dark. They may not know our world's name, just as we do not yet know theirs, but we share the same longing to understand, to survive, to exist beneath a sky that feels infinite. And so, as the data arrives, light curves, transits, spectral lines, we learn not only about them, but about ourselves. That perhaps Earth is not the ideal. Perhaps it's just the beginning. And among the stars, 1,000 better worlds are waiting. Quiet, enduring, breathing softly in the dark. Some planets race around their stars so fast that an entire year passes in less time than a single day on Earth. They move through their orbits like sparks flickering across a flame. Blazing, brief, and impossible to ignore. These are the ultra-short period planets, worlds that complete a full orbit in a matter of hours, not days, not weeks, hours. Among them is one of the most remarkable ever found, Kepler 78b. Kepler 78b is slightly larger than Earth, but it circles its star so closely that it completes a year in just 8.5 hours. Imagine that. The sun rising and setting hundreds of times in a single Earth week. The planet is so near its star that the distance between them is less than 3 times the diameter of the star itself. If it were any closer, it would be torn apart by gravity. The surface of Kepler 78b is a landscape of molten rock. Temperatures soar beyond 3,500 degrees Fahrenheit, hot enough to vaporize iron and turn stone into liquid fire. Its entire crust may be an ocean of lava, glowing orange and white beneath an endless day. There are no skies here, only heat and radiation. The planet's atmosphere, if it ever had one, has long since been stripped away by the intensity of its star. To astronomers, Kepler 78b is an enigma. It shouldn't exist. Worlds like this are expected to disintegrate or spiral into their stars, yet somehow, this one endures. Its orbit is stable, its density Earth-like, implying that beneath its molten shell lies a solid iron core, a heart still holding the planet together against impossible odds. When scientists first measured its orbit, they could hardly believe the numbers. A planet this small, this close, should not survive the forces acting upon it. And yet, there it was. A tiny world dancing on the edge of destruction, proving that nature writes her own rules. Every orbit leaves a trace. As the planet whips around its star, its gravity tugs ever so slightly, causing the star to wobble in measurable ways. From that subtle motion, we can learn its mass, its density, even its internal composition. In that sense, Kepler-78b is more than a curiosity. It is a window into how planets live and die under extreme conditions. The light from its star flares and pulses, and with each pass, the planet's surface reshapes itself. Lava cooling just enough to harden, then melting again under relentless heat. Over time, mountains rise and vanish, rivers of magma flow endlessly across the horizon. It is a world constantly remade, a perpetual creation and destruction in perfect rhythm. But Kepler-78b is not alone. There are others, like K2-141b, where supersonic winds carry vaporized rock from the day side to the night side, where it condenses, falls as molten rain, and is swept back again. A rock cycle unlike anything on Earth. The entire planet breathes in stone and exhales fire. Such worlds challenge our imagination of habitability. They remind us that a planet is not defined by comfort, but by gravity, orbit, and endurance. That even when heat becomes unbearable and the boundary between solid and liquid disappears, a planet can still exist. Silent, radiant, alive in its own strange way. If you could watch Kepler-78b from space, you would see it as a flicker, a glowing ember circling its star with impossible speed. Its night side would shine faintly red, lit by reflected fire from its molten oceans. Every revolution would cast a wave of light across the cosmos, a tiny pulse that says, "I am here. I am still turning." To us, it may seem like a place of torment, but to the universe it is a masterpiece of endurance, a world surviving in defiance of its own destruction. And in that defiance lies something deeply poetic, because even when surrounded by fire, even when every orbit brings it closer to its star, it keeps moving, keeps orbiting, keeps existing. A reminder that sometimes what defines life, and all that endures, is not peace, but persistence. For in a universe built on extremes, even a world of molten rock can be beautiful, simply because it refuses to disappear. If some planets race around their suns like sparks, others move so slowly that time itself seems to pause. Their orbits are not measured in days or months, but in centuries, even millennia. These are the slow dancers of the cosmos. Planets that circle their stars on paths so wide that a single year might last longer than the history of civilization. One of the most distant of these known worlds is Gu-Pisham b, a gas giant orbiting its star roughly 2,000 times farther than Earth is from the Sun. At that distance, sunlight is no longer warmth. It is memory. Its faint glow barely touches the planet's surface, leaving it in perpetual twilight, a cold giant adrift in its own quiet orbit. It takes Gu-Pisham b about 1,000 Earth years to complete a single revolution. For every time it returns to the same point in space, entire generations would have come and gone on Earth. Empires would rise and fall, oceans would shift, and our skies would change, all before this distant world finishes one slow turn around its star. Out there, the pace of existence feels different. Seasons might last for centuries, and night might stretch across decades. The sky would glow dimly with the reflected light of distant suns, while the planet itself drifts through a kind of frozen stillness. If it has moons, they would circle lazily, their orbits tracing delicate arcs against a backdrop of eternal dusk. Unlike the fiery chaos of the hot Jupiters, these far-off giants are calm, ancient, and nearly silent. Their atmospheres may be thick with methane or ammonia, their winds slow and steady, their clouds layered in endless patterns of ice. Every movement, every gust, every rotation takes place in slow motion, as though time itself had chosen to whisper here instead of roar. Ju Piscium b is part of a young star system, only a few tens of millions of years old. Yet its distance gives it a serenity that feels older than time. It may have formed closer to its star, then migrated outward, pushed by gravitational tides until it settled in the far cold outskirts. There, it found peace in isolation, turning through the dark like a frozen lantern. Such planets are difficult to find. Because they orbit so far away, astronomers cannot watch them complete a transit. Instead, they rely on direct imaging, capturing faint light reflected or emitted by the planet itself. These rare images show glowing points next to distant stars, proof that even in the outermost cold, planets continue to exist, quiet, resilient, and forgotten by light. In those regions, energy moves differently. The stars' radiation barely reaches. The chemistry of their skies slows to a crawl. Water, methane, and nitrogen freeze solid, forming layers of crystal that drift in winds slower than human breath. Lightning might still flash on occasion, a brief reminder that even silence can spark. It's humbling to think about a place like that, a world so far from heat, so detached from its star's warmth, that it lives in the edge of existence. Yet even there, it persists, kept alive by gravity and motion. A planet with no hurry, a world that measures time in patience instead of speed. And perhaps, in that slowness, there is wisdom. The universe is not only made of explosions and light, it is also made of endurance, of things that move so gently they almost seem eternal. If you could float near Ju Piscium b and look back toward its sun, you would see a faint, pale star suspended in blackness. Its light would be no brighter than the moon seen from Earth. All around you, the constellations would barely shift, their patterns unchanged for centuries. The only motion would be the slow turning of clouds below, their colors fading between shades of gray and blue. It would be easy to mistake such stillness for emptiness. But perhaps this is another kind of life, the quiet rhythm of a cosmos at rest. While hot worlds blaze and vanish in decades, these cold giants endure, watching eons unfold around them. Ju Piscium b will complete its next orbit in the year 3000, long after we are gone, still circling, still silent, a monument to cosmic patience, a reminder that not all movement must be fast to be meaningful, and not all beauty needs to burn to be seen. Sometimes, it is enough simply to keep turning, slowly, faithfully, beneath a star whose warmth can no longer reach you. Because in the great machinery of the cosmos, even the slowest orbit is still part of the dance. For most of human history, we believed our solar system was unique, that the 8 planets orbiting our sun were the only ones of their kind. The stars, we thought, were distant lights, beautiful but barren. And then, in the late 20th century, that illusion began to fade. In 1992, astronomers made a quiet discovery that changed everything. 2 small planets were found orbiting a pulsar, a dead, spinning star left over from a supernova explosion. They weren't like Earth, nor like Jupiter, but they proved one simple truth. Planets could exist beyond the sun. The age of the exoplanet had begun. A few years later, in 1995, came the discovery that truly opened the gates. Using a method that measured the gentle wobble of a star, scientists found a giant planet, 51 Pegasi b, orbiting a sun-like star just 50 light-years away. It was a gas giant like Jupiter, but far too close to its star. A hot Jupiter, a type of planet we never imagined could exist. And with that single observation, the universe became infinitely larger. Today, thanks to missions like Kepler, TESS, and JWST, we've discovered over 5,000 confirmed exoplanets. and the number continues to rise each year. Each one is a small point of data. A dip in starlight, a curve in motion, a whisper of gravity. But together, they form a symphony of worlds. Some are scorching and bright, orbiting so close that they complete a year in a single day. Others wander far from their suns, drifting through cold space for centuries. Some are made of ice, some of gas, some of metal, and some, perhaps, of ocean and rock. Each new discovery stretches our imagination a little further. The Kepler Space Telescope, launched in 2009, was the machine that truly transformed our understanding. It stared at a single patch of sky for nearly a decade, watching over 150,000 stars continuously, searching for the tiny, rhythmic dimming that meant a planet had passed in front of its star. From those flickers of shadow, Kepler revealed thousands of new worlds. It taught us that planets are not rare, but common. That nearly every star in the galaxy likely has at least one. Some of these planets orbit red dwarfs, small, faint stars that will live for trillions of years. Others circle massive, unstable stars that burn bright and die young. And still others, perhaps the most intriguing, exist in systems that look a little like ours. Rocky worlds near the center, gas giants farther out, and icy bodies on the edges. Each one tells a story about how nature builds, destroys, and rebuilds. When Kepler's mission ended, its successor, the Transiting Exoplanet Survey Satellite, or TESS, took its place. TESS scans nearly the entire sky, searching for planets around the brightest stars we can see. The data it collects has already revealed new candidates, some Earth-sized, some massive and strange, some orbiting stars that shimmer faintly in constellations we once thought were empty. But the story doesn't end there. New telescopes like the James Webb Space Blaze Telescope, JWST, have begun studying the atmospheres of distant planets, analyzing the faint colors of light that pass through their skies. From that light, scientists can detect water vapor, methane, carbon dioxide, and even signs of clouds. Each molecule is a clue, each spectrum a message from across the galaxy. The more we look, the clearer it becomes. Planets are not exceptions. They are the rule. The Milky Way alone may hold hundreds of billions of them. Some orbit bright suns, others drift through the dark with no star at all. And every one of them, from the fiery to the frozen, adds another line to the story of creation. It's astonishing to think that only a few decades ago we didn't know any of this. We didn't know that diamond planets, ocean worlds, or tidally locked giants even existed. We couldn't imagine glass rain, molten skies, or double sunsets. Now, we not only imagine them, we can measure their light, map their orbits, and even estimate their weather. Each discovery humbles us. Each new world reminds us how small we are, and yet how connected we remain to the universe around us. Every orbit, every shadow, every spectral flicker is a quiet confirmation that creation is ongoing. That somewhere, right now, a new planet is forming from dust and heat, its destiny unwritten. And maybe someday, someone there will look back toward the faint glimmer of our sun and wonder if they too are alone. Just as we wonder now, searching the skies for a reflection of ourselves, hoping that in the vastness of it all, the silence is not empty, but waiting to be answered. When you stare at a star through a telescope, its light seems steady, unwavering, eternal. But sometimes, if you look close enough, that light flickers ever so slightly, dimming by less than 1% for a few hours or days. And in that faint rhythm, astronomers hear the quiet footsteps of a planet passing by. This is the transit method, the way we discover worlds not by seeing them directly, but by watching the shadows they cast. When a planet crosses in front of its star, it blocks a tiny fraction of the starlight. The brightness dips, then rises again as the planet completes its orbit. To the human eye, it's imperceptible, but to precise instruments, it's a signature, a soft, repeated heartbeat in the light of the cosmos. Each transit tells a story. From the size of the dimming, we can measure the planet's radius. From the timing, we know its orbit. And by analyzing the starlight that passes through its atmosphere, we can detect the faint fingerprints of gases: water vapor, methane, carbon dioxide. Every flicker becomes a page in the diary of a distant world. It's extraordinary to think that nearly all the exoplanets we know were discovered not through sight, but through light patterns. Data points so subtle that they would vanish if you blinked. Space telescopes like Kepler and TESS have spent years collecting those tiny changes in brightness, watching stars blink in sequences that reveal unseen companions. The universe, it turns out, is full of these flickers, each one a quiet signal, a planet crossing the stage of its star. But transits are only part of the story. Another method, just as elegant, listens for a different kind of motion: the gravitational wobble. When a planet orbits a star, the star doesn't stand perfectly still. It moves slightly too, pulled back and forth by the planet's gravity. This motion causes subtle shifts in the star's light, a stretching and compressing of its wavelengths, like the changing pitch of a note. By studying this effect, called the radial velocity method, astronomers can measure a planet's mass, its speed, and even hints of its internal composition. The first exoplanet ever discovered around a sun-like star, 51 Pegasi b, was found this way, not by its shadow, but by its pull. The star swayed gently but persistently, as if tugged by an invisible companion. That wobble, recorded in tiny shifts of color, was the first whisper that another world was out there. Together, these two methods, transit and radial velocity, form the foundation of modern exoplanet science. They let us read the invisible, to reconstruct orbits and atmospheres from nothing more than the language of light and gravity. It's a reminder that seeing is not always believing. Sometimes it's listening to the small, rhythmic patterns that reveal something greater. In some systems, we've even seen planets and moons interacting, their combined gravity causing transit times to vary slightly. Those tiny delays hint that moons, exomoons, might exist, orbiting planets just as our moon orbits Earth. Each detection feels like deciphering a code written by the stars themselves, one that speaks of balance, harmony, and motion. As technology improves, we've begun to go even deeper. The James Webb Space Telescope can now capture the spectral lines of exoplanet atmospheres, the chemical fingerprints that tell us what these worlds are made of. Through these faint traces, we've already identified sodium, water vapor, and even traces of carbon-based molecules. And someday soon, we may detect something more: the subtle imbalance of gases that hints at life. Think about that. We are learning to sense the weather of planets hundreds of light years away, to read their clouds, their winds, their temperatures, from nothing but a star's flicker. We are, in a sense, listening to the breathing of distant worlds. The more we learn, the more the cosmos feels alive. Every dip in brightness is a reminder that stars are not alone, that each one may be surrounded by its own family of planets, a hidden chorus orbiting in quiet synchrony. It's humbling to know that with every blink of a distant star, somewhere, a world moves across its face, its orbit precise, its motion timeless. We will never see those sunsets, never walk those skies, but in their light, we can trace the rhythm of something beautiful, the dance between star and planet, light and shadow, seen and unseen. For every flicker tells a truth, that in the infinite silence of space, the universe keeps time. And through that rhythm, we begin to understand that we are not watching chaos, but listening to a heartbeat that's been pulsing since the beginning of time. Sometimes the shadows of planets tell us stories of escape, not the graceful kind, but the slow unraveling of worlds. Because not every planet holds onto its sky forever. Some lose it, breath by breath, until their atmospheres dissolve into the void. Around distant stars, astronomers have witnessed this quiet exhalation. Gas giants glowing like comets, their outer layers streaming behind them in long, delicate tails. These are planets in decay, their atmospheres heated and stripped by relentless stellar winds. In extreme cases, radiation from the nearby star heats the planet's atmosphere until it reaches escape velocity, the point at which the gas can no longer be held by gravity. Hydrogen and helium flow outward like vapor, forming trails that stretch for millions of kilometers. Some worlds become wrapped in halos of escaping gas, like luminous ghosts orbiting a distant sun. One such planet is HD 29458b, often called Osiris. It was one of the first worlds observed losing its atmosphere in real time. Seen through ultraviolet light, Osiris reveals a vast cloud of hydrogen flowing behind it, a comet-like tail created by the heat of its star. Every orbit, it sheds more of itself, turning slowly transparent as if melting into the fabric of space. For Osiris, survival is a delicate balance. It circles its star every 3.5 days, close enough that its upper layers are constantly ionized. Solar radiation tears at the atoms, and the planet bleeds skyward. Yet even as it fades, it persists, a testament to resilience in the face of annihilation. Other worlds tell similar stories. Planets like GJ 436b, another gas giant, also leave behind shimmering trails of hydrogen. It's as though they are evaporating, their shapes dissolving into cosmic mist. The sight challenges our sense of permanence. Even planets, seemingly solid and eternal, can vanish with time, their skies undone by the light that once gave them life. For smaller, rocky planets, the process is harsher still. Without thick atmospheres to protect them, they can be stripped bare in their youth. Stellar flares and winds scour their surfaces, turning lush beginnings into airless deserts. Some may once have had oceans, rivers, and clouds, but now orbit as lifeless embers, their atmospheres long gone. This cosmic erosion is more than destruction. It is transformation. Stars shape the destinies of their planets, sculpting them through pressure, heat, and time. Some are stripped down to dense metallic cores, the remains of former gas giants, now shrunken and exposed, orbiting close like molten embers. Others are reduced to vapor and memory, dispersed into the interstellar medium, their matter recycled into the birth of new stars and worlds. In that way, even loss becomes creation. The material torn from these planets drifts outward, mixing with cosmic dust, feeding the next generation of solar systems. The universe wastes nothing. Every molecule shed, every atom carried by stellar wind, becomes part of the next act in an endless play. For astronomers, these fading worlds are precious. They offer a glimpse into planetary evolution, a process that spans billions of years. By studying how atmospheres erode, we learn how others endure. We begin to understand why Earth's sky still holds, why our air remains, for now, our shelter and balance. It also reminds us how fragile that balance truly is. One small shift in temperature or solar activity, and the scales could tip. The same light that nurtures life can also take it away. When we look at Osiris or GJ 436b, we are not only observing distant chemistry, we are witnessing the poetry of impermanence, a cosmic reminder that nothing, not even a planet, is immune to change. And yet, there is a strange beauty in that impermanence. A planet glowing as it fades, its tail of light streaming behind like the final brushstroke of a dying sun. It is not tragedy, it is transition, an echo of how everything in the universe moves from one state of being to another. So the next time you look at the night sky, remember that somewhere out there, a world is exhaling. Its air is rising into space, its gravity letting go. And though it is vanishing, it leaves behind something timeless. A glimmer, a story, a lesson written in the light of a star. Even endings in the cosmos are just beginnings seen from another angle. Because in the silence between the stars, even as one world fades, another is already being born. The more we discover, the more the universe surprises us. Every few years, a new kind of planet emerges, something that challenges everything we thought we knew about how worlds should work. Some are too dense, others too light. Some orbit backward. Some glow, some freeze, and some spin through the dark with no sun at all. They are the cosmic exceptions, the rule breakers of creation. There are planets where the sky rains molten glass, others where clouds shimmer with vaporized metal, and a few where the air itself is made of stone dust. Each discovery feels like a dream written by the cosmos, proof that imagination alone cannot rival what nature creates. Consider the world known as WASP 17b, a planet so large yet so light that it could float on water, if there were an ocean big enough to hold it. It's called a puffy planet, one of a strange family of gas giants that defy our expectations. Twice the size of Jupiter, but with only a fraction of its mass. WASP 17b orbits so close to its star that its atmosphere expands like a balloon. The heat stretches the gases outward, turning the planet into a swollen sphere of light and air. Its density is so low that it's nearly transparent. The star's rays pass through its outer layers, revealing colors and chemical traces unlike anything in our solar system. Astronomers have even detected signs of titanium oxide in its atmosphere, a substance that on Earth is used in sunscreen, now drifting as vapor through alien skies. Winds roar across its surface at thousands of miles per hour, redistributing heat in waves, a balance between day and night that may never truly settle. Puffy planets like WASP 17b are fragile by nature. They exist in a kind of delicate equilibrium. Too hot, too close, too unstable to last forever. Some will eventually shrink as their atmospheres drift away. Others may spiral inward until they are consumed by their stars. Yet for the moment, they glow like living lanterns, a reminder that beauty often exists in the most fleeting forms. On the opposite extreme are ultra-dense worlds, planets so compact that their gravity could crush iron into new forms. Imagine a rocky planet twice the mass of Earth, but with the same diameter. Every atom is squeezed tightly together, its core a pressure cooker of metals and silicates. These planets are small but immensely heavy, cosmic anvils orbiting close to their stars. They may have formed after losing their outer layers in collisions, leaving behind only their metallic hearts. To walk on such a world, you would feel a pull twice, even 3 times stronger than Earth's gravity. Each step would feel like wading through stone. Between these extremes lie mini Neptunes, worlds neither truly rocky nor fully gaseous. They are wrapped in thick layers of hydrogen and helium, but they may hide vast oceans beneath their clouds. Boiling, metallic seas of water or ammonia under unimaginable pressure. Some may have no solid surface at all, just endless layers of vapor and liquid swirling toward unknown depths. Astronomers believe these hybrid planets are among the most common in the galaxy, yet we have nothing like them in our solar system. They are reminders that Earth's pattern is not universal. Nature has far more blueprints than we can count. And then there are the rogue planets, the wanderers without a home. Ejected from their star systems long ago, they drift alone through the dark, lit only by the faint warmth left from their birth. Some may still have internal heat, keeping subsurface oceans warm for billions of years. Others are frozen through, dead worlds carried by momentum, endlessly falling through the night between stars. It's a haunting thought. A planet with no sunrise, no seasons, no sky, only silence and the cold whisper of eternity. But perhaps the strangest worlds of all are those that orbit their stars backward. In most solar systems, planets spin and orbit in the same direction as their star's rotation, born together from the same swirling disk of gas and dust. Yet a few, like WASP 17b, defy that order completely. They orbit in reverse, against the spin of their suns. Something violent must have happened. A near collision, a gravitational shove, a cosmic accident that flipped the orbit upside down. And still, the planet holds its course, circling in defiance of the rules that made it. These rebellious worlds reveal the true nature of creation. The universe does not follow a single script. It experiments, it improvises. And in the vastness of that experimentation, we find endless wonder. Each discovery adds another thread to the cosmic tapestry. A dense planet here, a puffy one there, a rogue traveler passing through, a world of fire, a world of ice. Together they remind us that our universe is not predictable. It's alive with variation. When we think of planets, we often imagine familiar skies, blue, calm, breathable. But in truth, most worlds are nothing like ours. They burn, they freeze, they drift, they vanish. And yet, even in their extremes, they are magnificent. Because in every one of these strange discoveries, in every backward orbit, every glass storm, every dying sky, the universe is whispering the same message, that there is no single way to exist, no single way to shine. Some planets blaze for 1 billion years. Some endure in silence for 10 times that long. Some are born, some are broken, some are still forming in the dust as we speak. But all of them, everyone, prove the same quiet truth, that creation is infinite in its imagination, and perfection is never the point. In a cosmos as vast and strange as ours, every world, no matter how improbable, is a masterpiece simply because it is real. Not every world orbits in harmony. Some planetary systems are like symphonies, perfectly tuned, each orbit locked in resonance with the next. Others, though, are chaotic, a delicate choreography on the verge of collapse. The universe holds both, side by side. In some rare cases, planets move together in extraordinary synchrony. These are resonant systems, where one planet completes exactly 2 orbits for every 3 of another, or where 3, 4, or even 7 planets share an intricate rhythm. Each orbit protects the next from collision. Gravity pulling in perfect counterpoint. The result is not chaos, but cosmic music. One of the most mesmerizing examples is the TRAPPIST-1 system. Just 40 light-years away, it contains 7 rocky planets, each orbiting a cool red dwarf star. All 7 are locked in gravitational resonance. Their orbits linked like gears in a clock. The timing is so precise that if one planet completes 8 orbits, the next completes 5. The one beyond that completes 3. A repeating pattern that's held steady for billions of years. When astronomers first saw the data, they couldn't believe how stable it was. So many planets, packed so close together, should have pulled one another apart. But instead, TRAPPIST-1 hums like a perfect mechanism. If you could somehow hear it, each planet's orbit would produce a note. And together, they'd form a quiet harmony, a gravitational song playing endlessly in the dark. These synchronized systems are rare gifts of balance. They reveal how gravity, when given time, can sculpt even chaos into beauty. Every movement, every orbital correction, is a negotiation between worlds, a silent conversation held over eons. But not every planetary system is so lucky. Some live in the shadow of instability, where orbits wobble, where paths intersect, and where time itself feels temporary. In these places, gravity's balance is fragile. A small nudge, a passing star, a migrating planet, and the entire system can come undone. When astronomers run computer simulations of certain multi-planet systems, they often see futures filled with chaos. Planets collide, others are ejected into space. Some spiral inward to be swallowed by their stars. It can take millions of years, but instability always wins in the end. Such systems are reminders of how dynamic the cosmos truly is. Planets are not fixed. Their orbits evolve, drift, decay, and sometimes vanish. What seems permanent to us, a star with its family of worlds, is only a snapshot in cosmic time. Even our own solar system bears the marks of past violence. There is evidence that a planet once orbited between Mars and Jupiter, destroyed long ago, leaving behind the asteroid belt. Neptune and Uranus may have swapped places billions of years ago, and Earth itself likely gained its moon through collision. A glancing blow that reshaped both worlds forever. Creation and destruction are not opposites in space. They are partners. Some planetary systems still exist on the brink. They appear calm today, but their orbital paths reveal tension. Gravitational forces building quietly over time. Astronomers call them metastable systems, balanced for now, but doomed to eventually unravel. In 10 million years, maybe 100, planets will begin to drift. Collisions will occur, and gravity will rewrite the map once again. This instability isn't failure, it's evolution. Planets form, migrate, collide, and reform. Each act of destruction clears the way for something new. Moons emerge from debris. Asteroid belts give birth to new materials, and sometimes even life finds its chance in the aftermath. The cosmos is constantly editing itself, trading order for creativity. The ancient philosopher Heraclitus once said, "Nothing endures but change." Now, thousands of years later, astronomers watch that truth unfold across light years. They see worlds forming and falling apart, a dance of impermanence written in gravity and time. Even unstable systems hold a kind of beauty. Picture a world in one of these chaotic orbits, its seasons shifting wildly, its skies filled with unpredictable dawns. Sometimes two suns rise together, sometimes one vanishes for years behind the other. The tides rise and fall without pattern, and storms sweep the atmosphere in strange, repeating intervals. Life there, if it exists, would have to adapt not just to climate, but to the rhythm of disorder itself. And perhaps that's what the universe teaches most clearly. That balance is never absolute, and stability is never guaranteed. Even the most harmonious systems are only temporary arrangements. Beautiful for a while, then gone. So when we look at TRAPPIST-1 and marvel at its perfect orbits, or when we study unstable systems teetering toward collapse, we are witnessing two sides of the same truth: that existence is always in motion, that the music of the spheres is not a single melody, but an endless composition, with quiet harmonies and crashing chords alike. And through it all, gravity keeps time. Patient, impartial, turning chaos into art and silence into song. Every planet tells a story of survival, but some tell a story of death and rebirth, because not all stars live forever, and when a star dies, it does not always take its planets with it. Some remain, circling the remnants of what was once a sun, continuing their orbits through a landscape of silence and ruin. When a star like our sun reaches the end of its life, it expands into a red giant, swelling outward until it engulfs its inner planets. Mercury, Venus, perhaps even Earth. All could be consumed in that wave of fire. Then, in a moment of final brilliance, the star sheds its outer layers, leaving behind a small, dense core. A white dwarf, no larger than Earth, but with the mass of the sun. Its light fades slowly over billions of years, a glowing ember cooling in the dark. And yet, around these stellar corpses, we found planets still orbiting. Some survived the inferno, their orbits stretched but intact. Others may have formed later, from the ashes and debris left behind. They circle faint white dwarfs like moths around dying flames, their skies pale and cold, their suns dim and spectral. One such system, known as WD 1856 Plo 534, hosts a planet roughly the size of Jupiter. It orbits its white dwarf every 34 hours, skimming the very edge of survival. No one expected it to be there. The star's red giant phase should have destroyed it. And yet, somehow, it endured. Perhaps migrating inward after the chaos ended, finding a fragile new balance around a ghostly sun. Other worlds orbit even stranger remnants. Neutron stars and pulsars, the collapsed cores of massive stars that ended their lives in supernova explosions. These stars no longer shine with ordinary light. They beam radiation in tight, spinning columns, sweeping across the cosmos like cosmic lighthouses. And around them, impossibly, orbit planets. The first confirmed exoplanets ever discovered were found around such a pulsar, PSR B1257+12. 3 small, rocky worlds circling a dead star that pulses dozens of times per second. They are bombarded by radiation and magnetic storms, yet they remain silent witnesses to the aftermath of catastrophe. No one knows if they formed before the explosion or after, built from the wreckage that remained. Either way, they are proof that even death is not the end of creation. Astronomers sometimes call these zombie worlds, but the name feels too simple. They are not just survivors, they are continuations. Planets that live in the afterglow of collapse, that orbit stars which no longer shine, their light replaced by memory. Imagine standing on one of these worlds. The sky would not blaze with golden sunlight, but with a single point of pale blue or red, the glow of a white dwarf burning quietly in the dark. There would be no warmth, no day or night, only a long, dim twilight stretched across eternity. The air, if it existed at all, would be still. The stars would seem frozen in place, as though time itself had stopped. And yet, even here, life might not be impossible. If the planet had once held oceans or an atmosphere, the lingering heat from the white dwarf could keep pockets of water liquid for millions of years. It would be a fragile existence, but life has always favored persistence over comfort. The same could be true for worlds orbiting neutron stars. Their intense magnetic fields and bursts of radiation would make them hostile. But some scientists believe subsurface oceans or magnetic shielding could allow chemistry, even biology, to endure. In the heart of death, there may still be flickers of creation. Over time, as white dwarfs cool, they fade into black dwarfs, theoretical remnants that no longer emit light. The universe isn't old enough for any to exist yet. It will take trillions of years before the first ones form. When they do, they will mark the final stage of stellar evolution. Stars that have burned every atom of their fuel and gone completely dark. Even then, their planets, if still bound, will continue to orbit, unseen, unlit, moving endlessly through a frozen universe. It's almost poetic to imagine that someday, long after the last light fades, planets will still exist, turning quietly in the dark, their motion the only memory of stars that once were. Because in the end, planets are storytellers. They carry the scars of their stars' lives, the heat of their births, the chaos of their deaths, and the quiet rhythm that follows. They remind us that everything in the universe, from atoms to galaxies, is part of a cycle: creation, destruction, renewal. Even our own world, bright and full of life, is temporary. One day the sun will expand, and Earth's oceans will boil. Its skies will burn, its rocks will melt and flow. But maybe, just maybe, some remnant will remain. A moon, a fragment, a whisper, circling the cold, white ghost of the star that gave us life. And if someone, somewhere, in another epoch of the cosmos, were to look our way, they might see it, a tiny rock, orbiting a dead sun, and wonder who once lived there and what stories were lost with the light. Because in this universe, nothing truly vanishes. It only changes form, waiting for a new kind of dawn that no living eye will ever see. Not all planets are born from peace. Some emerge from violence, from collisions so vast they reshape entire systems. For as long as stars have burned, the cosmos has been a forge of destruction and renewal. Worlds are shattered, scattered, and reborn in endless cycles of gravity and dust. In the early days of a star system, chaos reigns. Dozens of young planets, still molten, still forming, move through unstable orbits, colliding again and again. Each impact sends waves of rock and vapor spiraling into space. From that debris, new worlds rise, heavier, smoother, more stable than before. Our own Earth was born from such turmoil. About 4.5 billion years ago, a Mars-sized body, known to scientists as Theia, struck the young Earth with incredible force. The collision melted both worlds, vaporized rock, and threw fragments into orbit. From that glowing debris, the Moon was born. Its creation was not a quiet event. It was a fiery storm, a wound that became our planet's most faithful companion. Now, we've begun to find evidence of similar collisions happening across the galaxy. Astronomers have spotted young stars surrounded by glowing rings of dust, the remnants of planetary impacts still unfolding. One system, called HD 1172555, shows signs of vaporized rock and silica, proof that two rocky worlds may have collided there not long ago. Another, ASASSN 21QG, offered something even rarer. The first possible observation of a planet's destruction in real time. A sudden flare of infrared light, too bright, too hot, suggested that a planet had collided with another, its death recorded in the faint pulse of heat and dust. To witness such events is to see creation and destruction entwined. A collision can erase a world, but from the ashes, gravity begins again. The debris settles, clumps, fuses, and one day forms something new. Every shattered planet becomes the foundation of another. Some exoplanets bear the scars of their violent pasts. Astronomers studying their spectra have found signs of metals and minerals that suggest extreme heat and pressure, conditions that could only come from impact. Their orbits too tell the story. Tilted, eccentric, looping around their stars like survivors of chaos. Each strange trajectory, a reminder that the path to stability is paved with ruin. And then there are the recycled worlds, planets built entirely from the remnants of others. These are the phoenixes of the cosmos, fragments fused by gravity into something whole. They may have strange internal structures, iron-heavy cores, uneven densities, even double crusts from multiple layers of rock merging together. To an observer, they would appear unremarkable, just another point of light. But beneath their calm surfaces lies a memory of cosmic violence. Imagine standing on such a world. The ground beneath your feet would once have been part of another planet, its surface now melted and reformed. The mountains might contain veins of glass from vaporized stone. The sky might shimmer faintly with dust still falling from ancient impacts. Every rock would be a fossil of collision, a quiet record of the storm that created it. Even moons can be forged this way. In some systems, giant impacts throw enough material into orbit to create not one moon, but several. Over time, those moons may merge or drift away, reshaping the system again. Gravity, patient and tireless, repeats its work until balance is found, if only for a while. Destruction and creation are not opposites. They are stages of the same process. Every star, every planet, every atom in your body was shaped by events like these. Explosions, collisions, transformations. The calcium in your bones, the iron in your blood, the carbon that makes you. All were forged in the hearts of stars and the heat of their deaths. So when we look at a planet like Earth and marvel at its beauty, we are seeing the result of unimaginable violence. Every sunrise, every ocean wave, every breath of air exists because something once collided, burned, and began again. The universe does not fear destruction. It uses it. It builds with it. From chaos, it carves order. From loss, it creates form. Perhaps that's the quiet lesson written across the stars, that even endings have purpose. That nothing, no planet, no life, no moment is ever truly wasted. It only changes shape, returns to the dust, and starts again. In that sense, every world, no matter how scarred, is a survivor, a testament to the resilience of matter and to the simple, endless truth that governs the cosmos. That everything, everywhere, is always in the process of becoming. Some planets are born in one home and end up in another. They are the interstellar travelers, wanderers that drift between suns, crossing the invisible borders of gravity's vast domains. In a galaxy filled with motion and collision, even worlds can be displaced, captured, or cast adrift. Astronomers call them interstellar or captured planets, but the name doesn't capture the wonder of what they truly are. They are cosmic immigrants, planets that began their lives orbiting one star, only to be torn away and adopted by another. Their journeys can take millions of years, their paths curved by chance encounters and gravitational tides. The Milky Way is not a quiet place. Stars move in clusters, passing near one another more often than we imagine. When they do, their gravity can twist the orbits of nearby planets, pulling one loose and sending it spiraling into the dark. Most are lost forever, becoming rogue planets, wandering without a sun. But every so often, one finds a new home, captured by the pull of a different star, falling into a new orbit as though it had always belonged there. It's a breathtaking thought that somewhere in the galaxy, a planet may be orbiting a star that did not give it birth. Its sky, its seasons, its sunlight, all borrowed. A world living under an alien sun, perhaps with the faint memory of another. We've even found hints of such systems. Some exoplanets orbit on strange, tilted paths that don't match the alignment of their host star's rotation. Their chemistry, too, is mismatched. Their elemental fingerprints unlike anything in their neighborhood. It's as if they were built elsewhere and moved later, like travelers carrying stories from distant skies. This isn't just speculation. Simulations of galactic dynamics show how easily it can happen. When two stars pass close to one another, especially in dense star clusters, their gravity acts like a slingshot. Planets can be pulled free, exchanged, or captured, each encounter rewriting the architecture of entire systems. In a galaxy of hundreds of billions of stars, these cosmic exchanges may be more common than we think. Imagine standing on such a world. Its sun might shine differently than the one it once knew. The colors of dawn would be foreign, its year longer or shorter, its seasons reshaped by the new balance of light and distance. Perhaps it would still carry the chemical echoes of its past. Frozen gases from a colder system, minerals forged under a redder sky. Even in its silence, it would be a world with a history, a planet that has lived more than one life. The idea raises a haunting question. Could life have once begun on a planet like this, survive ejection into interstellar space, and continue under a new star? It sounds impossible, but some scientists believe it might be. If a world had deep oceans beneath ice, or a thick atmosphere to preserve warmth, microbes could endure the long, cold journey. Then, when captured by a new star, they might awaken again, like seeds carried across the galaxy by the wind of gravity. The same mechanism that flings planets outward also creates rogue worlds, adrift in the eternal night between stars. They have no sunrise, no orbit, no seasons, only the faint heat of their own core, slowly fading through eons. We've detected some of them already. Their faint infrared glow revealing their presence in the black ocean of interstellar space. Each one is a monument to resilience. A planet without a home, still carrying the weight of mountains, the chemistry of oceans, and the possibility, however remote, of life. If life can adapt to survive radiation, vacuum, and ice, then perhaps even these loneliest travelers are not empty. Perhaps deep beneath their frozen crusts, something still moves, dreaming through the endless dark. It's humbling to realize how fluid the universe truly is. Stars move, planets drift, galaxies collide, and through it all, the story of each world is written not in permanence, but in motion. Our own solar system may not be immune. Billions of years from now, the slow migration of the Milky Way toward Andromeda will reshape the heavens. When the two galaxies merge, stars will pass near one another, and planets, maybe even ours, could be cast into new orbits or lost to the void. The night sky will change forever, and some future traveler might look up at a completely new constellation, never knowing where their world once came from. Every captured planet, every rogue wanderer, is proof that the universe is alive with movement. Nothing stays where it begins. Even worlds, heavy with oceans and stone, are ultimately travelers. And maybe that's the quiet truth behind it all, that the cosmos is not built to stand still. It flows, drifts, and rearranges itself endlessly. Stars exchange planets, galaxies trade light, matter becomes memory. So when we gaze into the dark and wonder if there's another Earth somewhere, perhaps there is, but maybe it didn't start where it is now. Maybe it too is a wanderer, finding peace beneath a foreign sun, turning slowly, endlessly, under skies that once belonged to someone else. When we look out into the galaxy, we are not just looking at distance, we are looking back in time. Every planet we discover is not only a place, but a moment, a frozen chapter in the long, unfolding story of the universe. Some of those worlds are so ancient that they formed when the cosmos was still young and dim, when galaxies were small and stars were only beginning to burn. These are the ancient worlds, planets that have been orbiting their stars for over 10 billion years. They were born when the universe had fewer elements, no iron, no calcium, almost no carbon, and yet, somehow, they formed anyway. From what little material existed at the time. One such system is known as Kepler 444. Its star is more than 11 billion years old, twice the age of our Sun. Around it orbit 5 small, rocky planets, each smaller than Earth. When these worlds were young, our own planet had not yet even begun to form. For billions of years they've circled their aging sun, long past the rise and fall of galaxies, quietly enduring as the cosmos around them evolved. Kepler 444 is a time capsule, a glimpse into the earliest architecture of the galaxy. Its planets may be barren now, scoured by time and radiation, but they remind us of something profound, that the process of planet formation began almost as soon as the stars themselves were born. Another ancient system, HD 140283, nicknamed the Methuselah star, is nearly as old as the universe itself. It may even predate some of the first galaxies. Though no planets have been directly confirmed there yet, evidence of heavy elements in its surroundings suggests that world building may have begun earlier than we once thought possible. If life ever arose on such ancient planets, it could have had billions of years to evolve, to change, adapt, maybe even vanish before our sun was born. It's a humbling thought that civilizations could have come and gone before Earth even cooled from its molten state. But not all old systems are serene. Some may still hold the echoes of violence. Asteroid bombardments, tidal fractures, orbital decay. Even after 10 billion years, gravity does not rest. It keeps sculpting, shifting, erasing. The universe, it seems, never stops editing its work. And somewhere, amid all that quiet persistence, there may still be warmth. Some ancient stars are surprisingly stable, red dwarfs that burn slowly, using their fuel so efficiently that they can shine for trillions of years. Planets orbiting such stars could experience stability far beyond anything we know. If life were to take root there, it could have more time than any life form in the universe. Ages to think, to evolve, to endure. Perhaps such life, if it exists, moves not with urgency but with patience. Perhaps its sense of time is beyond our comprehension. A civilization that measures its progress not in centuries, but in millennia. One that sees a million years the way we see a single day. The thought is both melancholy and comforting. That everything fades, but nothing truly disappears. The light that reaches us from these ancient systems is billions of years old, and yet it still travels, still illuminates, still tells its story. We may not last forever, but the echoes of our world, our signals, our light, our dust, will drift through space long after we are gone. And maybe someday, another civilization will find them, and see in them what we see in Kepler 444. A reminder that we were here, that for a brief, bright moment, we too were part of the ancient song of creation. When we gaze up at the night sky and imagine other worlds, we often picture places like Earth, calm, blue, and full of air. But some of the most fascinating planets we've discovered don't resemble Earth at all. They orbit tiny, quiet stars, the kind that shine faintly and live almost forever. Most of the stars in our galaxy, nearly 3 out of every 4, are red dwarfs, small, cool, and dim. They burn their fuel so slowly that they can live for trillions of years, hundreds of times longer than the sun will. If the galaxy were a forest, red dwarfs would be its roots. Invisible from a distance, but holding everything together. And yet, many of these modest little suns have planets. Some orbit so close that a year lasts only a few days. But even at that distance, the temperature can be mild enough for liquid water. Others circle within a fragile, habitable zone, a thin ring where warmth balances perfectly between freezing and fire. Astronomers now believe that these red dwarf systems might actually host more potentially habitable planets than all other stars combined. Among them is one of the most studied systems in history, TRAPPIST-1. 7 Earth-sized worlds orbit its small, reddish star just 40 light-years away. 3 of them, maybe more, could hold liquid water. Each one receives just enough warmth to remain temperate. The days are endless there. The nights are eternal, because most red dwarf planets are tidally locked, with one side always facing the star and the other lost in permanent darkness. The sun in that sky would never rise or set. It would hang forever near the horizon, casting an orange glow over one hemisphere while the other froze beneath starlight. Between those extremes lies a narrow twilight band, a ring around the planet where day and night meet, where light is gentle and shadows never move. If life exists there, perhaps it thrives in that soft half-light, neither burned by heat nor frozen by dark. To us, it would be an alien kind of world, one where the stars pulse instead of shimmer, where weather moves not from sunrise to sunset, but from fire to ice. Winds could howl across the twilight zone at hundreds of miles an hour, carrying clouds of vaporized minerals or ice dust. The concept feels surreal, but physics tells us it's real. These are the twilight worlds, planets suspended between extremes, balanced on the edge of 2 eternities. Red dwarfs are not without danger. They are unpredictable, especially when young, flaring suddenly and violently, releasing radiation thousands of times stronger than any solar storm on Earth. A single flare could strip a planet's atmosphere, erase its oceans, and sterilize its surface. Yet some planets may survive, protected by magnetic fields, thick clouds, or deep oceans that shield what lies below. Even beneath such volatile skies, life could adapt, evolve, and persist. It's a strange irony that the smallest stars might give life the greatest chance to endure, because while massive suns burn fast and die young, red dwarfs are patient. They outlive galaxies. They will still be shining long after every bright star has faded into darkness. If civilizations ever rise on these worlds, they could last for unimaginable spans of time, measuring history not in centuries, but in eons. Perhaps one day, when our sun is gone and our memory fades, beings on those faraway planets will still be watching their crimson skies, still telling stories under the same slow-burning light. Astronomers say that when the last bright stars die, trillions of years from now, only the red dwarfs will remain, each surrounded by faint, stubborn worlds. They will be the final witnesses of existence, the caretakers of the universe's last glow. Imagine that distant future. The galaxies will have drifted apart, the cosmic background gone cold, and yet somewhere, in a small patch of eternal dusk, a red star will still burn. Softly, patiently, its light falling on a quiet planet that has never known the meaning of night. Perhaps life will still be there. Perhaps it will look up, see the faint embers of dying galaxies in the black sky, and realize it is the last observer, the final consciousness in a universe now asleep, and still it will endure, because that is what the cosmos does. It endures. Through creation and destruction, through light and shadow, it keeps turning. Somewhere, right now, around a tiny star in the depths of space, another world is already beginning its story. A planet of twilight, a planet of time, a planet that may one day outlive the very stars that made it. Across the galaxy, planets come in every possible form. But some are so extraordinary that they defy even our broadest expectations. They orbit multiple suns, trace strange tilted paths, or shine brighter than the stars that made them. These are the worlds of wonder, the planets that rewrite the rules of astronomy itself. For centuries, science fiction imagined them. Worlds with two suns, like Tatooine from Star Wars, where twin dawns rise over distant deserts. Now we know such worlds are real. They're called circumbinary planets. And they orbit pairs of stars that dance around each other in gravitational embrace. When two stars orbit close together, their combined gravity acts as a single anchor. A planet can orbit both of them at once, moving in graceful ellipses through a sky where day and night are never the same. If you stood on such a world, you might watch one sun set while the other still blazed overhead, filling the horizon with twin shadows and double rainbows. The rhythm of light would be unpredictable, a cosmic choreography of brightness and eclipse. One of the most beautiful examples is Kepler 16b, the first confirmed planet found orbiting two stars. It's a gas giant, half the size of Jupiter, and though it's too cold for life, its existence proved something astonishing: that stability can exist even where gravity seems impossible. We've since discovered more circumbinary worlds, each one a reminder that nature loves symmetry, but never fears complexity. Other planets exist in systems with 3 or more suns, gravitational mazes where light never truly fades. Imagine a world orbiting within a trinary system, the first sun rising in the east, the second following hours later, and the third visible as a pale ghost near the horizon. There would be no true night. Shadows would layer, stretching and crossing until they disappeared. The temperature might fluctuate wildly, the seasons unpredictable, but the view would be magnificent. In 2016, astronomers discovered HD 131399 AB, a massive planet orbiting 3 stars. At certain points in its orbit, it would experience continuous daylight for months, 3 suns shining at once. Later, as it drifted farther away, it would plunge into a triple sunset, the light fading in sequence like a slow cosmic symphony. Such worlds remind us that even chaos can be beautiful. And not all stars in these multi-sun systems are alive. Some are remnants, white dwarfs or neutron stars, burned out cores still holding planets in their grip. To orbit one of these is to circle a ghost, a planet revolving around what once was light. Its days would be dim and haunting, its nights filled with the pale glow of memory. Beyond these tangled systems, there are planets with spectacular rings that make Saturn's look small by comparison. Astronomers have found hints of exoplanets whose rings stretch hundreds of times wider than Saturn's. One candidate, J14407b, may be surrounded by a ring system so vast it would span the distance between the Earth and the Moon. If such a planet were placed in our solar system, its rings would dominate the night sky, a glowing halo visible even by daylight. These grand cosmic architectures aren't rare accidents. They are the universe experimenting with form and balance, gravity shapes, light paints, and time sculpts. Each new discovery adds another layer to our understanding of how diverse planetary systems can be. But some of the most surprising worlds don't orbit stars at all. They orbit the collapsed remains of dead ones. We've found planets circling pulsars, dense neutron stars that emit beams of radiation. They orbit in silence, their skies filled with rhythmic flashes, a pulse of light every few seconds. As though the universe itself were keeping time. These systems are rare, and their origins are still a mystery. Did the planet survive the supernova that created the pulsar, or did they form afterward from its ashes? Either answer defies imagination. That's the quiet truth of planetary diversity. It's not randomness, it's creativity. The universe is not content with repetition. It builds in endless variations, filling every possible niche where matter and motion can coexist. And so, as we continue to explore, each discovery doesn't make the cosmos smaller. It makes it deeper. Because in every world, every orbit, every flicker of reflected light, we see a new possibility, a new way the universe has chosen to express itself. And if you listen closely, you might almost hear it. The faint, eternal hum of creation, reverberating through the dark, sung by worlds that orbit not in silence, but in harmony. Good night, and see you in the next video.